Ladies and gentlemen, Silvana Audia.
Here are the answers to the partner test for pre-calculus 3-4 to 3-6. Question number 1 was worth 5 points. The parent function is f of x is equal to the greatest integer x. So, to write the transformations, what I do begin doing is putting the parent function, greatest integer, in a box, and a parenthesis inside here. A shift of the graph 2 units to the right is going to be x minus 2. This is always the opposite of this number. The next step is to stretch this graph horizontally by a factor of 4. Horizontally, this number goes inside. This is the coefficient of what goes with x. But since you want to pull it out, this 1/4, you flip this number, this is going to be 1/4, not 4. You want to shift this graph down 6. This is the number that moves it up and down, so plus 6. To reflect something over the y-axis, you have a negative inside. And to compress something vertically by a factor of 1/2, that would go outside of the box. So your answer would be f of x equals 1/2 greatest integer negative 1/4 parenthesis x minus 2 box plus 6. This is the correct answer for 5 points. Now, you could also write this answer if you distribute this negative 1/4. You could also, for full credit, have 1/2 and negative 1/4 x, and then a 4 times 2, which is going to be a positive. A negative turned to negative is a positive. This is going to reduce to 1/2, and then plus 6. So I accepted either answer. Some students wrote this answer, and some left it like that. That is correct. Number 2. First, you have to take this function. G of x is equal to 4, and then it's the negative 4x plus 8. It's the cubic function minus 1. So the cubic function is, we're going to write f of x, this is your parent function, x cubed. That's your parent function. Now the transformations are done in a certain order. What you want to first do is pull this a value out. So you have g of x, I'm going to rewrite this as g of x equals 4, pull out the negative 4, and you're left with x minus 2, parenthesis, parenthesis, cubed, and then minus 1. So to start the transformations, you begin right here inside. That negative, that's your a, negative 4, that is your a value. So you're going to first say reflect over the y-axis. Then you flip this number. The reciprocal of 4 is 1/4. That number is less than 1, so it's a horizontal compression by 1/4. Then you move, this is your b. This is b. You're going to go 2 units to the right. And it's actually horizontally 2 units to the right. Then you come out here, this is your c value. That number, since it's greater than 1, it's a vertical stretch by a factor of 4. And the last thing you're going to do, d, is 1 unit down. And that's vertically 1 unit down. This was worth 6 points. 1 for the parent function, and 1 for each of these correct transformations. Number 3. How will we graph this function? First and foremost, the parent function is root of x. So what you're going to do is give me the ordered pairs. You're going to, if you were to graph this parent function, then we'll take numbers. What can I take the cube root of? We start with 0, 0, and we can plug in numbers like -1, -8, +1, and +8. If you were to take the cube root of -8, you get -2. Cube root of -1, -1. 0 is 0. Cube root of 1 is 1. And cube root of 8 is 2. So these are the numbers that go in your parent function. So -8, 2. I'm going to just transfer them here. If you wanted to see the graph of the parent function, it looks like this. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. So now what we need to do, we need to take this y equals 2 times the cube root of -1/2 x minus 1. We have to pull out this -1/2. So what you're going to do, erase this to give me some room. You're going to pull out this -1/2. So you end up getting y equals 2 times the cube root of -1/2, and then it would be x plus 2. You take 1, it's 1 over 1/2, which is 2. And it's a positive because a negative times a positive, we want that to be a negative. And minus 3. So now we're going to begin the transformations. You start right here. That would be your a value. So this is going to reflect your graph over the y-axis, and you're going to flip this 1/2, and it becomes 2. So you're going to multiply this number inside, has to be multiplied when you flip it, multiplied by all the x values. So I'm going to just write myself a little note here. What I'm doing, I'm going to multiply the x values by -2. Remember, you flip this number, and then you multiply all the x values by -2. So I'm going to divide this column into 2, x and y. Taking all these and multiplying them by -2, you get 16, 2, 0, -2, and -16. You're going to keep these y values the same. Next, so that's A. B means you're going to shift your graph 2 units left, which means you're going to subtract 2 from your x values. So you take your x values and you're going to subtract 2. So I'm going to divide my column into 2, x and y. I'm taking all these x values and I'm subtracting 2. You do the opposite. So what is 16 minus 2? It would be 14. 2 minus 2 is 0. 0 minus 2, -2. -2 minus 2 is -4. And -16 minus 2 is -18. You're going to keep your y values the same. Next, this is your c value. This number, you're going to multiply the y values by this number. Exactly the way it is. So you're going to take all the y values and do 2, because it's a vertical stretch by 2. You're going to do 2 times all the y values. So if we multiply all these y values by 2, we get -4, -2, 0, 2, and 4. We're going to keep all the x values the same. And the last thing we're going to do is D. This is going to shift your graph 3 units down. So what we do is take the y values and we're going to subtract 3. So if we subtracted 3, negative 4 minus 3 is negative 7, negative 2 minus 3 is negative 5, 0 minus 3 is negative 3, 2 minus 3 is negative 1, and 4 minus 3 is 1. You're going to keep the x values the same. Now what you have here are all your new ordered pairs that you're going to graph to make your new function. So if you were to go over 14 and down 7, obviously my graph is off the page, so we're going to see these two ordered pairs for last. But your center, this point 0, 0, moved from negative 2 to negative 3. So 0, 0, you go left 2 and down 3. Then we have 0, 5, so negative, this point will now be 0, negative 5. And this point will be negative 4, 1, 2, 3, 4, and down 1. And the other 2 points that are off the page are somewhere, it's going to be somewhere 14, negative 7, somewhere down here, and somewhere out here. So this is the graph. Of the new function. And this was worth 5 points. Next, number 4. What you're going to want to do on this one is pull out that negative 1. So you have y equals negative 2, and then times negative 1, x minus 6. You have to pull the negative 1 out of these two. What is this? This is the absolute value function. Its parent function is y equals the absolute value of x. It's shaped like a V, so we have 0, 0, we have negative 1, 1, we have negative 2, 2, 1, 1, and 2, 2. So if you were to graph the parent function, and you didn't have to do this, but this is what it looks like to graph the parent. So now, transformations begin. Start with, this is your A. That's your reflection over your y-axis. So what you're going to do here is multiply all the x values by negative 1. So we're going to multiply all the x values by negative 1. So you should end up getting negative 1 times negative 2 is 2. Negative 1 times negative 1 is 1. 0 times negative 1 is 0. Negative 1 times 1 is negative 1. And 2 times negative 1 is negative 2. You're going to keep your y values the same. Next, this is going to move your graph 6 units to the right. So now you're going to take all of your x values and you're going to add 6. So this is your b value. You're going to take x and you're going to add 6. So if you were to add 6, you get 4. Add 6 to negative 2, you get 4. I'm sorry. You're going to add 6 to 2. And you get 8. You're going to add 6 to 1 and you get 7. You're going to add 6 to 0, you get 6. You're going to add 6 to negative 1 and you get 5. You're going to add 6 to negative 2 and you're going to get 4. You're going to keep all of your y values the same. Next, this is a reflection over the x-axis. This number gets multiplied by the y values. So you're going to take all your y values and multiply them by negative 2. So if you multiply all these y values by negative 2, you should get, keep your x's the same. Negative 2 times negative 2 times positive 2 is negative 4. Negative 2 times 1 is negative 2. Negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times 2 is negative 4. The last thing, you're going to add 3 to your y values. If you were to add 3 to this, first let's leave all your x values the same. If you add 3 to this, you get negative 1. Add 3, you get positive 1. Add 3, 3. Add 3, 1. Add 3, negative 1. So now we're going to plot these points. 6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. That's your new vertex. Then we have 7, 1. And we have 6, 3 was our vertex. We had 8, negative 1. This is 8, negative 1. Then we have 5, 1. And we have 7, negative 1. So, 8, negative 1, 7, 1, 6, 3, 5, 1, and this should be, I copied this wrong, there's my mistake, it is 4, negative 1. Sketch the graph, and that is your new function. Next page. And that was worth 5 points. My question. So there was a total of 21 points on this first page. Next. How do you graph? This is your function f of x. We want to graph h of x where it's a negative 2 in front. What do you do with this? Well, first what you want to do, you're going to plot points on this graph. So we need to label this point. This is negative 1, 2, 3, 4. This is negative 1, 3. Then we're at 2, negative 2, 3, 2, and 5, 2. When you have a number outside, this number gets multiplied by your y values. So you're going to take this table of values, you're going to make a new table, and we're going to keep all of our x's the same. And we are going to multiply all the y values by negative 2. So you would get negative 6, negative 6, 4, negative 4, and again negative 4. So we're going to plot these points. Negative 4, negative 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Then we have negative 1, negative 6. We connect those two. Then we have 2, 1, 2, 3, 4. That's a third point. Connect those. We have 3, negative 4. 1, 2, 3, 1, 2, 3, 4. And we have 5, negative 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. And that is your correct graph. What this did, we are going to multiply all the y values by negative 2. That's a vertical stretch by a factor of 2 and a reflection over the x-axis. Number 6. This one, what it's telling you right here, this is a shift 2 units right and up 3. So simply all you had to do was take, you can use the ordered pairs if you need to use this T-chart, or what you could have done is moved each of these ordered pairs, knowing that you're going to get the same shape, 2 units to the right and up 1, 2, 3. And you could take this top part of the graph, and if you went 2 units over to the right and up 3, this one, 2 units to the right and up 3, and this one, 2 units to the right and up 3. You want to make a half circle. Just like that. That was worth 3 points. The next one. What is an even function? that means this graph would have symmetry to the y-axis. This is when you take your x values and you put the opposite. So I would take these ordered pairs in order from left to right and plot them. So we have -6, this point is -6, -2, and we have -2, 3, and 0, 0, and then we have 2, 5. So to graph the even function, to make this have symmetry to the y-axis, all you do is take your x values and change their signs. So you have 6, 2, 0, -2, but keep the y's the same. So if we plotted 6, -2, 1, 2, 3, 4, 5, 6, 1, 2, and we have 2, 1, 2, 3, 0, 0, and we have -2, 5, 1, 2, 3, 5. And your graph, if you were to fold this along the y-axis, both sides would match up perfectly. To make a function an odd function, which means it has symmetry to the origin, what you do, you take all your x and y values and you change both of their signs. So x's become the opposite and the y's become the opposite, whatever they are. So in order from left to right, this ordered pair is -4, 6. Then we have -3, 3. Then we have 0, 5. And then we have 2, 0. And then we have 6, 4. So what you would plot now, if you changed all the signs, you would plot 4, 3, 0, -2, -6, and then -6, this becomes -3, -5, 0, -4. So plotting these points over 4, 1, 2, 3, 4, 1, 2, 3, 4, 6. Then we have 3, -3. Then we have 0, -5. Then we have -2, 0. And last, -6, 2, 3, 4, 5, 6, 1, 2. And that is symmetry to the origin. Each of these graphs, 5, 6, 7, and 8, were worth 3 points each. Next, how do you test for symmetry? For y-axis symmetry, you're going to replace x, -x, into the equation. If you can simplify the problem and get it back to its original, then it has symmetry to the y-axis. So here we go. Y cubed equals 2 -x to the 4th minus 3 -x squared plus 4. Since these x's are all even powered, they simplify back to its original, because a negative times a negative is a positive. So yes, this has symmetry to the y-axis. So we circle this, and we also circle even, because if a graph has symmetry to the y-axis, it's an even function. Let's test for symmetry to the x-axis. You're now going to replace y or -y. So when you put a -y here, what's going to happen, because it's an odd power, it's going to stay negative. So if we try to multiply everything back by -1 to get this to be a positive y cubed, it's going to change these values, so we say no. This does not have y-axis symmetry. For origin symmetry, you replace both x or -x and y for negative y. So you end up with negative y cubed equals 2 times negative x to the 4 minus 3 times negative x squared plus 4. This is going to stay a negative y cubed, and these will change back to being positive x squared next to the 4th. So this one, you cannot get this back to its original state. So it does not have symmetry to the origin, which means it's not an odd function. These two are the same thing. Neither means it's not even or odd. So those are your two answers. This question was awarded 5 points, 1 for each correct answer and 1 for all your work for each symmetry test, so 5 points. Number 10, same thing. For y-axis symmetry, you're going to replace x for negative x. This one will not work because this is going to be a negative right here. So you have we'll say no, you cannot get that back to its original. So this does not have y-axis symmetry, so it is not even. For x-axis symmetry, you are going to replace y for negative y. And since this is an even power for y, and it's the only one, when you do that, I can tell you right now, but you do have to show proof. This goes back to its original. So this is a yes. So if it has x-axis symmetry, you will circle that. But this last one, when you replace both x and y, you will not be able to get this problem back to its original due to the fact that this is an even power. So if you clean this up, this is a no. Origin, it's not origin symmetry, it is not an odd function, so you should have neither circle. This was worth 5 points. Again, 1 for each answer, 1 for each proof. Next. The next, you are going to add two functions. How do you add these two functions? 4x squared minus 8x plus x minus 2. Simplify this, and you would get 4x squared minus 7x minus 2. 2 points for that one. F minus g, you're going to take the f function, 4x squared minus 8x, and you're going to subtract x minus 2. So that means you have to distribute the negative. And simplify, the final answer will be 4x squared minus 9x plus 2. F times g of x. You're going to take 4x squared minus 8x, and you're going to multiply it by x minus 2. So you would FOIL 4x to the third minus 8x squared minus 8x squared, and then plus 16x. If you simplify these two, you should get 4x cubed minus 16x squared plus 16x. For f, g over f of x, you take the g function, divide it by the 4x squared minus 8x, and you always simplify. This problem says to take out the 4x, common numbers between 4x squared and 8x are 4x minus 2. These two cancel out, leaving a 1 in the numerator over 4x. This notation is a composition. You're going to plug f of x into the g of x. So you're going to take the f of x function and you're going to plug it into g of x. So what you do, here's your f of x, it goes right in there. So you have 4x squared minus 8x, and then minus 2. And that would be your answer. There's nothing you can do there. And the last composition, you're going to take g of x and plug it in to f of x. So what we're going to do now is this function goes in here. We have 2 x's. So now we have 4 times x minus 2 squared minus 8 times x minus 2. We're going to need to simplify this by squaring the x minus 2. You get x squared minus 4x plus 4. And we can distribute this, negative 8x plus 16, multiply this by 4. And in standard form, the answer in simplified is 4x squared minus 24x plus 32. For 12, you're going to take 4 and plug it into the g function. So 4 times 5 is 20. And 20 minus 4 is 16. Square root of 16 is 4. So then what you do is plug 4 into the f function. 4 times 2 is 8. Minus 1 is 7. So your final answer is 7. For 13, you're going to plug 1 into the f function. 2 times 1 is 2. 2 minus 1 is 1. So you're going to do g of 1 now. When you plug 1 in here, 5 times 1 is 5. 5 minus 4 is 1, and the square root of 1 is 1. And we're going to stop there and continue.